Good morning, grade 10. In this video, we are going to check the exercises that were given as homework. Page 175, number 6. Before taking off, a plane starts from rest and travels 800 meters in 20 seconds. Assume that the acceleration is constant and calculate A. They need the acceleration, and B. They need the speed, the last speed, V2. Okay, your mistake is that you are still using A equals delta V over delta T to calculate A. You cannot use this formula to calculate A in these exercises. Whenever you have A or you have accelerated motion, you have to use x equals half AT squared plus V0T plus x0. I have T equals to 20 seconds. V0 equals to 0 because they said it starts from rest. X0 equals to 0 unless they tell you that it started at the starting position, let's say 20 meters. And the final position is equal to 800. So I have all I need to calculate A. 800 equals half. A, it's the unknown, and 20 squared. So 800 equals half A times 400. 800 equals 200A. In this case, A equals 4 meters per second squared. This is for part A. Now, for part B, this is A. For part B, I have to calculate the V. So, V equals AT plus V0. This is 0. Now, this is known, it's 4, and T equals to 20. V equals 4 times the 20 equals 80 meters per second. In case you use the formula in here, delta V over delta T, you'll get the same answer in this part. In these parts, to calculate A, you're not allowed to use this formula anymore. So if you use it here, it's V2 minus V1 or V0 over 20. This is 4 equals the unknown minus 0, the starting, over 20, you get V2 equals 80 meters per second as well. You can only use it in this part. You cannot use it to calculate A anymore. Okay? This is for number 6. Now, number 7. Okay. Figure 15.11 shows the recording of the motion of the center C of a puck thrown on a horizontal air table. The marks on the paper are separated by equal time interval. Tau equal 1 over 50 seconds. The successive positions of C are C0 at time T0, C1, T1, and so on, where T0 is taken as origin of time. A. Compare the distances traveled by the puck in equal time intervals and include. So if you measure the distance between each 2 points, you'll get approximately 1.7. Between C1 and C2 as well, 1.7. 1.7. Between C3 and C4, 1.7, 1.7, 1.7, and finally 1.7. And as we know, between each 2 consecutive times, I have the same interval of time, which is tau 1 over 50 seconds. So compare the distances traveled by the puck in equal time intervals. Conclude. What can we say? We can say that I'm covering the same distance with the same time, the same distance with the same time, same distance with the same time. And when I have same distance with the same time, it means the velocity or the speed is going to be constant. It means I'm not going to have acceleration. So between C0 and C1, I have 1.7 centimeter. Between C1 and C2, I also have 1.7 centimeter. C2 and C3 1.7 centimeters, C3 and C4 1.7 centimeters, C4 and C5, C5 and C6, and finally C6, C7 1.7 centimeter. Each one of these is covered exactly using 1/50 seconds. So I have same distance covered with same time, which means I have a constant velocity. V equals constant, and whenever V equals to constant, I have uniform rectilinear motion and A equals to 0. I don't have acceleration. B. Calculate the average speed of the puck between any two instants you choose. Let's take between C2 and C6. You can choose any two instants you want. First, C2, C6 equals, from C2 to C6, I have 1, 2, 3, 4. 4 times 1.7. Now we will calculate it. And the time, the delta t, is 4 time interval, so 4 times 1/50. Now, the answer is going to be 4 times 1.7 equal, 6.8 centimeter, and 4/50, 0.08. Now, I need the speed. So V equals C2 C6 over delta t. Pay attention to the units because this is in centimeter, it has to be in meters. So 6.8 times 10 minus 2 over 0.08, and the answer will be 6.8 times 10 minus 2 over 0.08. It's equal 0.85 meters per second. This is the average speed of the puck between any two instants. Okay, let's take another example. Let's say you will choose C1 between C1 and C3. C1, C3 equals 2 times 1.7, and the delta t in this case equal to tau, yani 2 times 1/50. This one is equal 3.4 meters seconds. So in this case, the velocity is equal, this is centimeter, 3.4 times 10 minus 2 over, let's calculate it, 2/50 equals 0.04 seconds. 0.04, and you'll get 3.4 divided by 100 divided by 0.04. The answer is 0.85 meters per second. As you can see, it's the same speed that we got if we choose C2, C6. It's the same speed you will get no matter what are the points that you will choose. Now, C. Calculate the instantaneous speed of the puck at any 3 instants you choose. Let's choose at C4. To calculate the instantaneous speed, remember we have to take one before it and one after it. So let's call it V4. It's equal C3 C5 over 2 tau, because it's always 2 tau between 2 points. So C3 C5, it's 2 times 1.7 over times 10 minus 2, of course, over the answer we got over here. We will get 0.85 meters per second. Let's see at C6. V6 equal, you have to take C5 and C7 over 2 tau. it's also 2 times 1.7 times 10 minus 2 over 0.04. You'll get 0.85, and this is how, whatever points you choose, you will get the same answer. So what's the conclusion in here? I have constant velocity. The average speed is equal to the instantaneous speed, which take us to D. I need the average acceleration now. What's the average acceleration? To calculate any acceleration in these problems, remember, in these problems, you have to use v2 minus v1 over 2 tau. So equals any two instants. Let's say we took the two instants C1 and C2. So we have to have v2, which is the instantaneous speed at C2, and v1, the instantaneous speed at C1. Let's calculate them. v2 equals C1 C3 over 2 tau equals C1 C3 over 2 tau is equal to 0.85. We have calculated it previously. Now v1 equals C0 C2 over 2 tau equals C0 C2. It's also 2 times 1.7 times 10 minus 2 over 0.04. We will also get 0.85 meters per second. So A equals V2 equals 0.85 and V1 equals 0.85. So A is equal to 0. The acceleration is 0. What can I conclude in this case? No acceleration. It means E, what is the nature of this motion? It's a uniform rectilinear motion. A equals to 0, B equal constant. And that's it for number 7.